think it's on for Wednesday.
No, it's off for tomorrow.
Nah, it's Wednesday, bro.
No, it's Wednesday. It's listed as, stop, hey, stop. 3.3, graphing systems of linear inequalities is on the quiz.
So they don't, it's not on Tuesday. It's on Tuesday.
Our quiz is on Wednesday. It's on Power School's Wednesday. It's on Power School. Okay, yes, it is. 3.3, graphing systems of linear inequalities, okay? So we're going to talk about how to graph linear inequalities, which I think you've done in the past. We kind of did it a little bit with absolute value already, okay? This time it's just going to be with a line. A solution of a system of inequalities is an ordered pair that is a solution of each inequality in the system, okay? It says, for example, 5, -2 is a solution of the system above. The graph of a system of inequalities is the graph of all the solutions of the system. So this is where we're going to shade one side or the other, okay? Graphing each inequality in the system, you may want to use colored pencils or different colors of pens or highlighters. I don't care which one you want to do, because you're going to graph two lines on the same graph, and then you're going to shade and see if they cross their paths anywhere. Does that make sense? Okay, or not. So I would suggest using two different colors on your homework at all times. It will help you decipher things a little bit better. Okay. And then the second step is to just identify the region that is common to all of the graphs, which there might not be any solution. The graphs may never overlap. It kind of just depends. So we're going to do this. Yeah, the rest of these slides are pretty much just examples of graphing all of this stuff. Yeah, you're going to have more homework today. No.
We have the worksheet that's.
That's why I told you to do a lot of the worksheet.
Okay.
Okay. So it wants you to graph the system of inequalities. It wants you to graph y is greater than -2x minus 5 and graph y is less than or equal to x plus 3. So we should know how to graph these because in the last chapter we were graphing inequalities. I should say some of us were graphing inequalities. Some of us were trying to figure out what an inequality was. So we're going to apply that, which shouldn't be anything new. And we're going to take a look at what this looks like. Okay, if I want to graph this one right here, y is greater than -2x minus 5. Where do I start? Where do I start that graph at? The y-intercept. What's my y-intercept? -5. So I'm going to go down to -5, 1, 2, 3, 4, 5. I'm going to put a mark. And then what is my slope? -2, so down 2 over 1. Or I can reverse it and go 2, 1 this way, right? How do I get there? It's not a vertex, it's a y-intercept. I got it from the y equals mx plus b form. Okay, so I'm going to go down 2 over 1, or I'm going to go up 2 and over 1 this way. Now, is this line dotted or solid?
Dotted.
Dotted. This is hard for me because I don't have a perfect graph. Okay, so we're going to pretend. Okay, there we go. So it's dotted, okay? And then from there we can choose to do, well, let's just graph the second one, then we'll come back and we'll shade where we need to. Okay, here it says y is less than or equal to x plus 3. How do I graph that? Go to +3, put a point for my y-intercept, and then what's my slope? 1, 1, so up 1 over 1. Up 1 over 1, or I can go down 1 over 1. Dotted or solid?
Solid.
Solid, good Cam. Solid line, solid line. Okay, now I have to do shading for both of these, okay? For the red one, I'm going to plug in 0, 0 because it's easy. I'm going to say 0 is greater than -2 times 0 minus 5. Is 0 greater than -5?
Yes.
Yes. So I'm shading everything on this side of my graph, where 0 is. Now, I'm going to plug in 0, 0 also for the green one because it's easy. And I get 0 is less than or equal to 0 plus 3. Is 0 less than or equal to 3?
Yeah.
Yes.
God
So
bless
that's a true statement, so I shade
Never heard you sneeze.
down. okay? And your solutions for these two equations is everything in the area that overlaps. You don't have to name a point or anything unless it asks you specifically, pick one point out of that overlap. But for the main part, that's how you're gonna do it. You're gonna graph it that way, and that picture would be your solution points. So anything that's red and green is a solution. Does that make sense? That's why I want you to have two colors tonight.
That's all we doing?
That's all you do.
Really?
Wait, so
That's
you.
not the end of, we're gonna look at two more just to
I
get
feel
it.
like there's a trick into this.
No, that's all you're doing. You're graphing your inequalities, you're shading, and boom, that's all we're doing right
So
now.
if it asks us to give us a point,
So if it asks you to give a point, you could say, 0, 0, because we tested both of those points and we know they're both solutions. I could say 1, 1, you could pick any point
Any
that's
point.
in that shaded area that overlaps, okay? Let's look at another one. Okay, so this time, they give us inequalities, but they're not in y on one side, so we have to switch them first. So we do have to do a little bit extra work here. Okay, so we do have to do a little bit of extra work, but it's not too bad, so let's take a look at this. Okay, so here we go. This one says 2x plus 3y is less than 6. How do I change that around? What do I need to do? Okay, so how do I start that? Subtract 2x so that I get 3y is less than negative 2x plus 6. Then what do I do? Divide by 3.
3.
So I get y is less than negative 2/3 x plus 2. Now I can graph that. Let's start there. Where do I start this graph?
Positive 2.
Good, Tyler. Y-intercept, positive 2. What's my slope?
Go down.
Down to
Over 3.
over 3. Down to 1, 2, 3. Or I can go up 2 and reverse it. 1, 2, 3. If I can count, that would happen. Oh. Dotted or solid? Dotted. Tyler. Do you want to shade now or later?
Never.
Later? Okay. Now, let's look at this equation here. It's already in y equals 4, or it has y by itself. So where's my y-intercept? Positive 4, right? So positive 4. And, wait, I didn't graph that first one right, did I? Oh, no, I did. I didn't graph this last point. I want to go to positive 4.
Is that -2 and -3?
What are you talking about?
The second one? Is that
It's
both?
just, no, just the rise is negative.
No, I'm talking about on the one, -2 first. It's just the rise is negative?
Yeah, like I go down 2 and then over. Okay. Okay, so this one has an intercept of 4, so 1, 2, 3, 4, let's put that in the right spot. What is its slope? Negative 2, 3. Okay, Tyler tells me it's parallel, he's right, I'm gonna go down 2, and I'm gonna go over 3. What do we know about parallel lines? They have the same slope, but what do we know about, like,
They
they're never going to
intersect.
intersect, right? They're never going to intersect, 1, 2, 3, so something like this. Dotted or solid line?
Well,
Solid.
I just don't like turning my head.
Okay, so if they're never going to intersect, do you think there's going to be overlap in the solutions?
No.
No, okay. So here's what you're gonna do. You're still gonna plug in points. Let's plug in 0, 0 again. So I have 0 is less than negative 2/3 x plus, or negative 2/3 times 0 plus 2. So I get 0 is less than 2. Is that a true statement? Yes. So I'm going to shade everything down because that's where 0, 0 is. Then I'm going to come up here and I'm going to plug 0 into this one. 0 is greater than or equal to negative 2/3 times 0 plus 4. Is 0 greater than or equal to 4? No. So I do not shade where 0 is, I shade away. is an example. We did an example of one that cross, okay? We did an example of one that's parallel. We're going to do an example of one with one absolute value and one line. That's where it's gonna get, yeah. That's where it gets a little bit more fun, okay? How do we feel about that? Can we handle doing that right now? Okay. So you're just graphing the line. Don't forget it has to be dotted or solid. On some of your guys' test, you forgot to make it dotted instead of solid lines when you're graphing it, okay? And don't forget when you plug things in to check your shape. Okay. Next one. This one has an absolute value with it, okay? So that means we have to remember how you graph an absolute value. The first one's easy though, because it's just y is greater than, does it say greater than? Y is less than or equal to 3. That's a pretty easy one to graph. Okay. So I want to graph this first one. Y is less than or equal to 3, what do I do? You do what? Yeah, it goes through y at 3. It goes through y at 3. Is it dotted or solid? Solid, and it's going to go horizontally. Okay, horizontally. Okay, we'll come back and shade in a second. Let's take a look at this one here. Y is greater than x plus 4. To graph an absolute value on, because it says y is greater than the absolute value of x plus 4, what do you first have to identify?
Vertex.
Vertex. What's your vertex?
Negative 4, 0.
No.
I'm just kidding, 4, 0.
No.
Negative.
-4.
Negative 4.
I said negative 4, then you said no.
You said 4, 0.
Oh, I said negative 4, then you said no. Then I said 4.
Negative
then you
4.
said
Negative 4, 0. My vertex is negative 4, 0. Okay, so I go down to negative 4, 0. I go to negative 4, 0. 1, 2, 3, 4. Right? And I put my point. Now, does this graph face up or down? Up. It faces up. There's no negative on the outside. Is it having a dilation or is it shrinking or stretching at all? No.
No.
Okay, so I literally am just going to plug in a point. I'm going to plug in negative 3 because it's close to it to figure out what the point is that I get out. So if I plug in negative 3, I have y is greater than negative 3 plus 4, the absolute value of that. So y would be greater than 1, or y would equal 1. So one of my solution, or one of my points can be negative 3, 1. So I go to negative 3, 1, and then I have to reflect that. Remember that part? Dotted or solid?
Dotted.
Dotted. Okay, now we have to plug in points. I'm going to do 0, 0 for both again because it's just easy. If I do 0 for the first one, 0 less than or equal to 3, is that true or false?
True.
True. So I know the green is getting shaded down.
The second one is not true.
If you plug a 0 in, let's see. If I plug in a 0, I say 0 is greater than 0 plus the absolute value of 4. So then 0 is greater than 4. That's not true. So I have to shade inside of my V. Okay. So I think on your homework, the tricky ones are going to come when you have to do absolute value. Because I think on our last test, that was like where we struggled the most was absolute value. Okay? But that's what you're looking at doing tonight. Graphing inequalities in absolute value form or in linear form, shading, figuring out what solution points are for it. With that, of course, we have to throw in one word problem because that's our favorite thing to do. It says a discount shoe store is having a sale as described in the advertisement shown. Okay, so it says save 10 to 50% on all footwear where regular prices are $20 to $80. Use the information in the ad to write a system of inequalities for the regular footwear prices and possible sale prices. graph the system of inequalities, use the graph to estimate the range of possible sale prices for footwear that is regularly priced at $70. So let's start with the first thing. How can I create inequalities off of that? This is interesting. This one's hard. I think there's going to be 4 different inequalities. So it says, what are your regular price shoes? $20 to $80. $20 to $80, right? So I know if I just make that, let's say I make this part my x, okay, right here. I can say x is greater than or equal to what? What's the minimum? 20, okay? That's one equation, okay? So x is greater than or equal to 20, but x is also what? Less than or equal to 80. So I have 2 inequalities right there. Do you see how I got that? Does that make sense? Okay, so I have 2 inequalities with that. So one is representing the maximum price, okay, and one's representing the minimum price. Because I have 2 for the x, I'm going to make the sales part my y, okay? I'm going to make this part my y, which means I'm going to have 2 equations there too because I have 10 to 60% off, okay? This one's a little bit trickier. How could I represent that? If I take 10% off, how much of a percentage are you paying? 90%, okay? So one of my inequalities can say y is less than or equal to 0.9 times my x value. Because I could have 90% of something that I'm paying, okay? Or I could have, if I take 60% of something, how much percentage are you paying? 40. So my other inequality could say y is greater than or equal to 0.4 times or 0.40 times x. Okay? Because if I take 40% of that, so now I have 4 inequalities to graph. Not hard inequalities to graph. Hard inequalities to come up with, but not hard to graph. So if I go to graph these, this is a very
I hate the picture they use.
why the cat?
It's on a taxi. I said it.
Because taxis advertise all the time.
Yeah, but like, why? This.
Why do taxis
Yeah,
advertise?
no, why pick a taxi? Like, why not pick a billboard or like a sign? Like,
This book is from 2004 or something like that.
It's a question. These people trying to make
Because Tyler, these people hate you. That's really what it is.
You know, you're probably right.
Okay. So now, how do I graph these? What do I do to graph these? How do I graph? Let's start with the red. X is less than or equal to 80. What do we want to count by on our graph? 20s. Okay. Do you want to count by 20s to make it easier on our line? So if we count by 20 there, and count by 20 going up, we'll make it a little bit easier. Okay. So if I count by 20, that means X is less than or equal to 80. I'm going to go 20, 40, 60, 80, right? And then what type of line do I create? Straight.
Like the not dotted.
Right. Like this.
Yeah.
Okay. So I have a line there. Then I'm going to graph X is greater than or equal to 20. Okay. So X is greater than or equal to 20. I go to 20. I graph this line. Beautiful. At Y, you have Y is greater than or equal to 0.4 X plus 0. So I don't have a Y-intercept there, correct? Okay, so it starts at 0, 0. And it's going up by 0.4, which is, I'm trying to think of 2/5. Up 2/5, right? Yes. Because 4 over 10 is 2/5. So it's going up 2/5. So this is hard to graph when it's this small, but it's gonna look something, it's gonna be a solid line, right? It's gonna be something like, just gradually gets larger. Okay. The other one is 0.9, so it's going to have a larger, gap. Actually, let's read this. Let's make this the 0.9 line, because I'm having trouble fitting it along here. Let's make this one. Okay. So those are the 4 lines we need. Now we need to shade everything. What satisfies this statement? If I say 0 is less than or equal to 80, is that true?
Good.
Yes. So for that one, I shade everything going this way. Okay? Is 0 greater than or equal to 20?
No.
No, so I shade everything going this way. See how messy and fun this can get? Now, here, if I plug a 0 in and say 0 is greater than or equal to, what do I want to plug in? I don't want to plug in a 0 because it's on 0, 0. Let's say you plug in a 1, 1. 1 is greater than or equal to 0.4. Is that true? Yes. 1 is greater than or equal to 0.4. So if I plug in a 1, 1, I shade wherever 1, 1 is. So I'm going to shade in this region here. I probably should have used 4 colors on this. If I plug in a 1 again, 1 is less than or equal to 0.9. Is that a true statement? No.
No.
So I can't shade on the inside of that one. I have to shade, or I can't shade on the outside of that one. I have to shade on the inside of this one. So my overlap region is this whole segment, basically from right here to right here. That's where my profit can be made, okay? So I graphed it. It says use the grapher to estimate the range of possible sale prices for footwear that is regularly priced at $70. So if this is 20, 40, 60, 70 would be right around here. So it would be someplace in this region right here would be how much $70 ones usually are. Which we can't really come up with off of this graph. But that's what they would want to know. Where's the range that would be? So that's what they're looking for when they're talking about that. On your homework tonight, if it's large numbers like this and they ask you for a range, just estimate what you think it is. So this one comes out to be 28, I think, is less than or equal to y, and y is less than or equal to 63 is what they're looking for this part. But once again, we don't have graphing calculators, so we're not going to be able to pinpoint that down. So just give a rough estimate of what you think it would fall in, okay? Don't like stress too much about it. So 28 is less than or equal to y, and y is less than or equal to 63. And that's what you're doing on your homework tonight, graphing inequalities.